This video covers section 12.6 and 12.7 in the Klein textbook. The first section we'll discuss is 12.6, which is the preparation of alcohols via Grignard reagents. What is a Grignard reagent? These are reagents that are prepared by treating alkyl or aryl halides, specifically alkyl and aryl chlorides and bromides, with magnesium metal. Examples include chlorobenzene, reacting with magnesium to form this reagent where magnesium is inserted between the carbon and chlorine bonds. And then in a second example, we have magnesium inserted between a carbon-bromine bond. In this reagent, because carbon is more electronegative than magnesium, the carbon-magnesium bond is polarized to give more electron density to the carbon atom. So you can think of this reagent as ionic, although the magnesium carbon bond is actually a polar covalent bond, but this is essentially what your reagent is going to be acting like, is like benzene with a lone pair and a negative charge. This is similar to lithium aluminum hydride and sodium borohydride, where the aluminum hydride and boron hydride bonds are the nucleophiles. Here, the carbon-magnesium bond is the nucleophile. In a Grignard reaction, the general reaction is one where you have a carbonyl carbon, and you are adding an R group to the compound. So the R group is your nucleophile, and that added to the carbonyl carbon to give you an alcohol. An example of this reaction is shown next, where we have a ketone that is treated with methyl magnesium bromide. So here we've got the methyl group and that bond to magnesium as our nucleophile, and then in the product, that is the methyl group that we see. Let's look at the reaction mechanism for the Grignard reaction. We start off with our ketone, and then we've got our nucleophilic carbon-magnesium bond, so that's where our arrow is going to start, is at the nucleophile. And then we're looking for the electron sink, which is the carbonyl carbon, and recall that this is our more electropositive atom in the carbon-oxygen pi bond. Then we have to break that carbonyl bond to give oxygen a lone pair. This makes an alkoxide. In step 2, the alkoxide is protonated by water, giving us the formation of the alcohol plus hydroxide. This reaction works with other R groups as well. For example, we can have phenyl magnesium bromide, and then we're adding a phenyl group to the carbonyl carbon. The next section involves the protection of alcohols. Sometimes you need to conduct a reaction of an alcohol where the OH group would be reactive and therefore is incompatible. Here you need what's called protecting groups. Let me illustrate this concept by showing how we would accomplish the following transformation. Imagine if you wanted to convert the following bromo alcohol into a diol. What if you did this? You treat the bromo alcohol with magnesium, and then the ketone reagent that you'll need to form the alcohol and add two methyl groups, and then water. The reagent that you want to form will not form because the magnesium bromide group, or the carbon nucleophile, would react with the hydroxyl group. So what we need to do is temporarily change the OH group into something else that doesn't react with the Grignard reagent. The idea of protecting groups is that you take your original reactive group and you want to make it unreactive by adding something to it. Then you accomplish the reaction that's desired, in this case a Grignard reaction. Here we treat our alkyl bromide with magnesium and we get to our Grignard reagent. We're adding to this acetone, which is going to give us the addition of the two methyl groups and the oxygen. So if we were to draw just a quick mechanism for that step, this would be an attack of the carbonyl carbon by that carbon-oxygen bond, and that gives us the two methyl groups and the hydroxyl being a neutral compound after treatment with water. In the next step, you want to take this protecting group and remove it so that you have a diol again. A variety of protecting groups exist. We're going to use what's called the TMS group, which is the same as Si methyl methyl methyl. That's the TMS group. To introduce this to an alcohol, you want to use the reagent TMS chloride, and that needs to be accompanied by a base, which in this case is triethylamine. Those sets of reagents give you the oxygen atom that's now protected with the silicon and three methyl groups. And this is stable in a variety of reaction conditions, except that we want to avoid acidic conditions and sources of fluoride ions, because that's actually what removes the protecting group in step 2. Which is actually going to be a later step. You wouldn't do this right away. You'd accomplish the transformation that you want to accomplish on another functional group, and then you do the deprotection. TBAF is tetrabutyl ammonium fluoride. That's your fluoride source. Let's revisit our example where we're trying to convert bromopropanol into this diol over multiple steps. Now, instead of going directly to the magnesium, we are protecting the alcohol with TMS chloride. Then we accomplish the transformation that we want to accomplish to convert that bromide into an alcohol with two new methyl groups. And then we deprotect with TBAF, or tetrabutyl ammonium fluoride. Let's look at the reagents to see how that works. We start with bromopropanol, treat with TMS chloride, and that installs the protecting group onto the oxygen atom and makes it unreactive. Then in our next transformation, we're taking magnesium to form the Grignard reagent between that carbon-bromine bond. And then we're adding acetone. And let's look at what we're adding. We've got two methyl groups that are attached to this original carbon atom, and the alkoxide that forms from the carbonyl oxygen atom. Then when we treat with water in the next step, we protonate that oxygen atom to get to the neutral alcohol. And in our last step, we need to take this TMS group and remove it to form the alcohol, and we do that with our TBAF. Alternatively, we could use acidic water. This is probably the most challenging concept of this chapter, so I want to do a practice problem that goes over protecting groups. So here we've got a practice problem where we're trying to convert bromophenol into this diol compound, and I want you to pause your video and think about how you would go about this transformation. So pause your video to think about this, and then when you are done coming up with a set of transformations, then you can play the video again. Let's look at the structure of the product and see what's new to this product. we have five carbon atoms and a hydroxyl group, which implies that we're doing a Grignard reaction, treating a Grignard with 3-pentanone. So this is going to be what installs the 5-carbon chain. So normally we would do that by converting this bromine atom into a Grignard reagent, but we've got this alcohol group that's incompatible, so we need to protect that alcohol first before we can do the Grignard reaction. So we're going to first install a TMS group to make that alcohol unreactive. Then we're going to make our Grignard reaction reagent, our Grignard reagent. We'll treat this with (3-pentanone). Treatment with water is going to neutralize our alkoxide to form an alcohol. And then in our last step, we want to remove the protecting group to get to our phenol compound. Let's fill in the reagents that we need here. TMS chloride with triethylamine. Then we want magnesium to make our Grignard reagent. The 3-pentanone to provide the carbon source, and then water to neutralize our product, and TBAF or acidic water to remove the TMS group. I hope this video was helpful. If you have any questions, feel free to Canvas message me or post to Piazza.